Good day to you, everyone. You're welcome to class. We are looking at coordinate geometry in further mathematics at this beginning. And in coordinate geometry, we talk about locating points on the Cartesian plane. The Cartesian plane can be well regarded as your graph sheet, or is a good representation shown by your graph sheet or your graph paper. We can talk about plotting points on that graph paper as locating points on the Cartesian plane. A point can be located when we have x and y coordinates. As you have been taught in your mathematics class, you can be able to plot points when you have x and y values, which we call x and y coordinates. Now, in the year 9 class, you were taught how to plot straight line graphs. In such graphs that you drew in year 9, you had a straight line graph, which means you joined points together to form a straight line. Now, everything we're going to talk about here on this coordinate geometry, we have to do with the straight line. So we can talk about, or we will be talking about finding the gradient of a straight line. We'll also be talking about finding the middle point or the midpoint of a line segment. We'll also be talking about finding the distance between 2 points on that straight line. Now, what is a slope or what is a gradient? Gradient refers to the steepness or slopiness of a line or of a straight line. For example, you can say I have a straight line here. How slopy it is or slanty it is, that is what we refer to as the gradient or the slope of the line. Now, a line slope can either be positive or it can be negative. Now, particularly what I want you to take note of here is the formula for calculating the gradient or the slope of a straight line. Now, we have right here that you can work out the gradient of a line if you know 2 points on the line. If you know 2 points on the line, you can work out the gradient of the line. Now consider my line here in red. I will talk about these points which I have indicated here as x1, y1, and also another point on the line which I will be calling x2, y2. You can see that there. If I'm talking about the gradient of this line, I can find that with just these 2 points that are given or that is already known for this line. Now, the formula for finding the gradient of a straight line is simply y2 minus y1 over x2 minus x1. You can see the formula right here given, y2 minus y1 over x2 minus x1. Now, the letter m you're seeing right there is the representation of our gradient or slope. We use the letter m to represent gradient or slope. It could also, we could have also written or spelled out gradient here instead of just writing m. So take note that m represents the gradient, or the gradient can be represented by m. Why the 1, the 2, and the 1 that are written against the x and the y values is just to differentiate the point, to differentiate that this point that we call x1, y1 is different from this point that is x2, y2. It simply refers to the change, the gradient that we're talking about here, or the formula for gradient we're talking about here, refers to change in the x in the y value to the change in the x values. So we get right to calculation. We get right away to problem solving by taking a few examples. Now, the first example we'll be looking at says calculate the gradient of the line which passes through 2, 3 and 5, 7. Now, the first thing you would do is to indicate which of these points you'll be calling your x1, y1 or your x2, y2. That is very important. That's the first thing you should do. So in my own case, my x1, y1 is going to be my 2, comma 3, as you can see, and my x2, y2 will be my 5, comma 7. The next thing is to recall the formula for the gradient, and that is m equals y2 minus y1 over x2 minus x1. Next, I'll substitute the values that I've called my x1, y1, x2, y2 into the formula, and then what I have will be 7 minus 3 and then 5 minus 2. You must be very careful not to make a mistake with the points that you are substituting in the formula. That is the essence of actually labeling the points x1, y1, x2, y2. Now for my calculation, you see my gradient is going to be 4 over 3. I have a positive gradient. Now let's take a look at another example that says calculate the gradient of the line which passes through minus 2, 7 and 4, 5. Minus 2, 7 and 4, 5. Next, we solve by actually indicating which of them will be our x1, y1. And for my own problem here, my x1, y1 is minus 2, 7. And I've decided to call my x2, y2 4, 5. Now, the next thing is to recall the formula which says m equals y2 minus y1 over x2 minus x1. Next is to substitute the values into the formula, and then I do the sum. Of course, that will be very easy, just like the first one. Take note of your negative signs. So we have 5 minus 7 and 4 minus 2. Take note that this minus here is the minus in the formula, why the minus against the 2 came with the 2 or came with the point that is minus 2. So in working that or simplifying that, I'm going to have 2 over 6. 2 over 6 minus 2 over 6 rather, and that simplifies to minus 1 over 3. Now let's step up our calculation by taking a look at this problem that says calculate the gradient of the line which passes through 2d, minus 5d and 6d, 3d. Now again, my x1, y1, my x2, y2, and then my formula, and then I substitute into the formula the same procedure. Substitute into the formula. So I have 3d minus 5d over 6d minus 2d. And simplifying, I get 8d over 4d. In simplifying that further, I'm going to get 2 as my gradient. So 2 is the gradient for this particular problem. Now, lastly, we're going to have this one that's slightly different. It says the line joining 2, minus 5 to 4, a has a gradient of minus 1. Calculate the value of a. Now, the difference between these and the other ones we have solved earlier is that we are given the gradient here, and we are given 2 points through which the line that we are finding is, that the gradient is given, passes through. The line or the straight line in this question passes through 2, minus 5 and 4, a. We are given the gradient, but we are given a point or a value, we are given a point which has a value of y as a. It means that we do not know the value of y at this point, 4, a. So we have to find that value. Remember, the first thing to do again is to indicate which of them is your x1, y1. The same method procedure goes, and then you recall your formula. Then easily you substitute everything into the formula. You have minus 1 as m because minus 1 is given to us as a gradient. Then we substitute our a and our minus 5 for y, and then we substitute our 4 and 2 for x. Then we simplify that. Of course, that will give us minus 1 equals a plus 5 over 2. Now cross multiply, that will give us minus 2 equals a plus 5. Now if I simplify further by collecting like terms, my a is going to be equal to minus 7. So definitely that is the end of this problem solving on gradient of a straight line. In our next video, we will be looking at the distance between 2 points and we'll also be talking about midpoint of a line segment. I hope you do have a nice day. Thank you.